Welcome to this presentation. This is a brief lecture titled Confabulations, Not Hallucinations, a Psychiatric Perspective on Redefining Artificial Intelligence Errors. This will be the lecture outline. After an introduction to artificial intelligence, we will look at the concept of AI hallucinations. Then we will move on to hallucinations and confabulations in psychiatry. I'll make the case for using confabulations or hallucinations in characterizing AI errors. We will then go through some reasons as to why correct terminology matters before concluding. Artificial intelligence or AI refers to systems capable of performing tasks that normally require human intelligence. AI aims to replicate human cognitive functions such as learning and reasoning. Examples include problem solving, data analysis, and language comprehension. AI integrates principles from computer science, mathematics, psychology, and neuroscience. AI can be broadly divided into three types: narrow AI, general AI, and super AI. Narrow AI, also called weak AI, is focused on specific tasks, includes search engines, virtual assistants, and recommendations. General AI or strong AI is a theoretical system capable of all human intellectual tasks. It is still speculative. Super AI, also called artificial superintelligence, is the hypothetical future of AI where it surpasses human abilities in all aspects, including emotional intelligence. We will now look at some key concepts in AI: machine learning, neural networks, deep learning, and natural language processing or NLP. We will briefly look at each. Machine learning enables computers to learn from data and make decisions without explicit programming. Neural networks are computational models inspired by the brain's structure with interconnected neurons for processing information. Deep learning uses multiple layers in neural networks to identify complex patterns in large datasets. Natural language processing enables AI to understand and generate human language. AI in everyday life now include voice assistants such as Siri or Alexa, which understand and respond to speech. Recommendation algorithms. For example, Netflix uses AI to suggest films and TV series by analyzing one's viewing history, ratings, etc. Self-driving technologies use AI to recognize road signs, detect obstacles, and make real-time driving decisions. Medical applications have promising potential in areas such as early disease detection, diagnosis, and treatment development. Chatbots, AI models like ChatGPT, answer questions and assist with various tasks through conversational interaction. We will now move on to AI hallucinations. AI hallucinations are inaccurate, nonsensical, or entirely fabricated outputs generated by AI large language models. But these errors are presented by the AI in a convincing way. This phenomenon is becoming increasingly concerning as AI is steadily integrated into everyday decision-making processes, including healthcare. We will now look at some causes of AI hallucinations. Pattern misidentification. AI models may incorrectly recognize patterns in vast data sets without truly comprehending the information. Data ambiguity. When data is incomplete or uncertain, the AI fills gaps with plausibly rational but partly or wholly incorrect information. Misplaced conviction. AI systems often present information with a high degree of certainty, lulling the user into a false sense of confidence. What are some of the risks of AI hallucinations? The risks associated with AI hallucinations are significant, particularly in high-stakes areas. In medical fields, for instance, AI could provide misleading health advice or concoct research findings, which can have dire consequences. In legal contexts, it might result in incorrect legal interpretations or advice. Even in consumer applications, AI hallucinations may cause confusion or misinformation, potentially eroding trust in these technologies. What are some of the mitigation strategies against AI hallucinations? Researchers are actively working to enhance AI's ability to handle ambiguous information more transparently, such as acknowledging when the system does not know an answer. Techniques like reinforcement learning with human feedback are part of the efforts to improve AI's decision making by aligning it with human preferences and guiding it through complex and unpredictable situations. As AI continues to evolve, it is crucial for users to remain aware of its limitations. We will now look at the concepts of hallucinations and confabulations in psychiatry. Hallucinations and confabulations are two distinct, well-defined psychopathological phenomena in psychiatry. They represent disruptions in reality perception and memory, respectively. Understanding these phenomena and their associated disorders is critical for clinicians as it will help guide both diagnosis and treatment. A hallucination is a sensory deception in which a perception occurs in the absence of any external stimulus, yet experienced as real by the individual. Hallucinations can involve any of the five senses, with auditory hallucinations being the most common type encountered in functional psychotic disorders such as schizophrenia. Hallucinations in other sensory modalities are more often associated with organic conditions like delirium, dementia, epilepsy, etc., or disorders of substance misuse. Hallucinations have also been classified into several other types, and not all hallucinations are indicative of an underlying pathology. Those who are interested in learning more about phenomena like hallucinations, delusions, obsessions, etc., can watch my lecture titled Descriptive Psychopathology, which is available in this YouTube channel. Confabulations, on the other hand, involve the creation of false memories without the intention to deceive, arising from gaps in memory. They are characteristically seen in patients with Wernicke-Korsakoff syndrome. This syndrome is typically due to thiamine deficiency caused by a long history of alcohol misuse. Confabulations are also found in other organic disorders like dementia and traumatic brain injury. Confabulations are classified as either spontaneous, which occur without prompting, or provoked, which emerge in response to a question or cue. These fabricated memories are seemingly plausible, sometimes elaborately fantastical, and are effortlessly expressed by the individual. The case for using the term confabulations rather than hallucinations in characterizing AI errors. The term confabulations is a more fitting descriptor for errors made by AI than hallucinations because it aligns better with the nature of these inaccuracies. As mentioned above, confabulations refer to the unintentional fabrication of memories, either partially distorted or wholly false, that helps to camouflage gaps in a person's recollection in order to present a superficially coherent narrative. Similarly, AI systems generate erroneous outputs by combining data in a plausible but ultimately incorrect way without any intention to deceive. The AI's output is merely a response based on its training data and algorithms, filling in gaps when it encounters uncertainty with wrong information ranging from minor inaccuracies to wholesale concoction. Hallucinations in psychiatry, as mentioned earlier, refer to sensory experiences that appear real to the patient but are created entirely by his or her mind without any external basis. Thus, the term hallucinations pertains to a false perception rather than the generation of a plausible content. Applying the term hallucinations to AI inaccuracies could mislead users into thinking that the technology is experiencing something akin to a perceptual error. So adopting AI confabulations would more accurately reflect the limitations of AI as a pattern recognition system that sometimes constructs inaccurate responses grounded in its training data. This nomenclature better captures the idea that the machine's output is an artifact of its information processing strategies rather than an intentional distortion. This terminology provides a more precise and appropriate conceptual framework for understanding AI-generated errors. Let us now look at an example. A researcher asks an AI chatbot for a set of key references on a particular topic. On reviewing the answer manually, it is clear that one of the references is a pure fabrication. But on the surface, it seems authentic with all relevant details such as author names, article title, journal, date of publication, volume, page numbers, DOI, etc. When the researcher inquires further, as if the reference is genuine, the chatbot freely expands its fictitious material, giving an abstract PubMed ID, full text link, journal website link, funding information, etc. If, on the other hand, the researcher challenges by asserting that the reference is false, the chatbot immediately apologizes and then gives another believable but equally spurious reference. These characteristics of the chatbot's output are almost identical to those of confabulating patients reported in the neuropsychiatric literature. The typical patient with Wernicke-Korsakoff syndrome fills gaps in their memory with plausible but false information. When the clinician gives the impression that they accept such a patient's report at face value, the latter continues to elaborate on the original material. However, when refuted, the patient is highly suggestible and very quick to change the story to another totally different, outwardly persuasive, but equally untrue set of events. Just as verifying information provided by AI with dependable sources is an essential safeguard against AI hallucinations, it is likewise important to corroborate the details provided by a potentially confabulating patient with a reliable informant. Why correct terminology matters. Precision and clarity. As highlighted above, the term confabulations more accurately reflects the basis of AI errors, which are unintentional and fabricated without intent to deceive. This is in contrast to hallucinations, which imply a sensory experience without any external stimuli. Correct terminology avoids stigma. The term hallucination carries with it a heavy clinical association with psychotic disorders such as schizophrenia. Misapplying this term to AI can inadvertently reinforce societal stigma surrounding these conditions, conflating human experiences of mental illness with technological malfunctions. Using the term confabulation avoids this predicament and promotes a more respectful and accurate discourse. It is worth noting that colloquially, confabulation can also refer to an informal conversation characterized by a free exchange of ideas, somewhat similar to the interaction between a chatbot and its user. Educational value. Proper understanding and application of the terms can serve as an instructional tool by helping to elucidate the differences between the infinitely dynamic and complex human intellect and the much more mechanistic AI. Enhanced research focus. Clear and accurate terminology can guide research efforts more accurately, ensuring that studies on AI errors are grounded in appropriate conceptual frameworks. And finally, correct terminology encourages nuanced conversations. Adopting precise language can stimulate deeper discussions about the ethical, psychological, and social implications of AI development and contribute to a sophisticated dialogue about the nature of the limitations of AI, thereby fostering more realistic expectations of its capabilities. Some concluding remarks. By drawing on the psychiatric distinctions between hallucinations and confabulations, I have demonstrated that the term AI confabulations better reflects the nature of AI errors than the currently used AI hallucinations. As AI continues to progressively permeate various aspects of daily life, using precise language to characterize its limitations is crucial. Accurate terminology can also effectively guide future research and development aimed at creating more reliable and trustworthy AI systems. That brings us to the end of this presentation. Hope you found the information useful, interesting, and stimulating. Thank you for watching.